Hey guys, welcome to today's lesson. We're looking at the general equation of a parabola as a locus. Now you might think we've already done that. We've done the x squared equals 4ay as a locus, where a is the focal length. Well, that's true, but that's when the vertex was at the origin. Okay, so what happens when it's not at the origin? Well, that's something really good question. Think about our circle, x squared plus y squared equals r squared, because that was also at the origin of 0, 0. What did we write when it was not at the origin? Well, we wrote x minus h all squared plus y minus k all squared equals r squared when it had a center of hk. And believe it or not, it's pretty much the same for our equation of the parabola. Instead of having x squared, we have x minus h all squared equals 4 times a, and y would just be y minus k. That's when the vertex is at h comma k. Alright, now how does that work? Alright, let's look at a question. Now this question, believe it or not, it actually will be a vertex of an easier question. Alright, so let's have a look at this. We've got a vertex at 0, 3. So 1, 2, 3. Now that's my vertex, it's not the focal length. Okay, that's my vertex. It's concave up, so it's going to look like this. Alright, and we have a equals 3. So 3, 4, 5, 6. So that's going to be my focal length there, as you can see, which means my directrix, if that's 3, my directrix is going to be the actual x-axis, so y equals 0. That's what it's going to look like. Now, you don't have to draw that out all the time, guys. I just like doing it when we're starting because it gives you a bit more sense of what's going on here. Okay, just making sure that's your a value, which in this case is 3, as we are told in the question. Okay, so let's look at the formula. X minus h all squared equals 4 times a times y. So we know h and k, or h is 0, so we've got x minus 0 all squared equals 4 times a, which is 3, times y minus k. Well, it's y minus 3. So now it's a matter of expanding everything like we've done previously. So x minus 0 is just x, so we've got x squared, which equals 12 times y is 12y, and 12 times minus 3 is minus 36. Chuck it all on the left hand side. X squared minus 12y plus 36 equals 0, and I've got the answer to my very first question. So you can see it's pretty straightforward. Remember, you can use this formula whether it be at the vertex is at the origin or not. You can still use this formula. Okay, so pretty straightforward. Let's have a look at the next question. Find the equation of the parabola that has a vertex of 1, 1. Okay, again, I'm going to draw this up just so I can see what it's going to look like. So 1, 1, so that's where my vertex is going to be, and has a focus of 1, 8. Okay, 1 and then 1 all the way up here. We'll put that as 8. Okay, so that's my focus, and that's my my vertex. Now, because of that, obviously, my directrix would have to be underneath it. So the difference between there is 7, okay, which means that A is equal to 7. Because remember, your focus is directly above your vertex, and however many amount it's gone up, that's your A value, your focal length of 7. Which basically means if I want to draw my directrix, or I'm guessing it's going to be down at about minus 6, I think that would be probably right. Okay, that would be your y equals minus 6, which is your directrix. And then it'd be drawn in something like this. Ooh, kind of didn't go through there. Okay, but you can sort of see what my parabola is going to look like. A very rough sketch. Okay, so let's use the formula yet again. Again, I've drawn it, guys. You don't need to draw this. If it helps you to figure out what that a equals 7, then certainly you can do that. But my formula is x minus h all squared equals 4a times y minus k. So h and k are 1 and 1. So x minus 1 all squared equals 4 times a, which is 7, and then times y minus 1. So I'm going to expand it out now. So I get x squared minus 2x plus 1 equals 4 7s are 28 times y minus 28. Chuck it all on the left hand side. We get x squared minus 2x minus 28y plus 29 equals 0. Bob's your uncle. Okay, you can see here that realistically the diagram wasn't massively important, but certainly it helps to figure out what that a value is, and I like drawing it anyway. It makes a bit more sense of it. Okay, the parabola has a directrix of y equals 5 and a focus of minus 3, 3. Okay, let's draw this out. Again, I think it's good to start doing this. It gives you a bit of a sense of what it's going to look like. Okay, so let's put on here, the focus is at minus 3, 3. So 1, 2, 3, and then 1, 2, 3. So that's where my focus is going to go. The directrix is at y equals 5, so that's 4, 5. So it's going to go through here. That's my directrix. Okay, y equals 5, and I'll put in brackets directrix. Okay, so this case, if my focal length is below the directrix, it basically means that the vertex must be halfway in between the focal length and the directrix, which means that halfway between 3 and 5 is going to be 4, that line there. So it means that this point here is my vertex, which means it's going to be an unhappy face graph. Alright, so you can see what I mean by drawing it. It makes it a lot easier because now I can clearly see that a is equal to 1. So if I'm looking at my equation, we've got x minus h all squared equals 4 times a times y minus k. So x minus h is going to be minus 3 squared equals 4 times a y minus k. Expand it out, we get x squared plus 6x plus 9 equals 4 times y minus 4 times 3 is 12. Pull it to the left hand side, x squared plus 6x minus 4y, 9 plus 12 is 21 equals 0. I've got it. I hope you can see, guys, that this isn't actually too challenging. It's all pretty straightforward. You do more and more of these questions because I would suggest, guys, that this is the one you're going to see most often. Okay, these type of questions where you are given a center that is not going to be the origin. All right, have a play around with it. I think it's exercise 10.6 in the 2-unit book or exercise 11.6 in the green extension 1 or 3-unit book. Any problems, guys, let me know. Otherwise, have a fantastic day.